into this. And the material is becoming, as you can see, not quite difficult. That can become more and more dependent on the material. If you don't pay attention to chapter 3, you will have very difficult in chapter 4. Let's say chapter 3. Now, chapter 3, not chapter 4, multiple random variables. Random of C, which is chapter 6, will be completely independent. You have the sixth camera in chapter 5, correlation with covariance camera. I said with ABCD to chapter 6. So if you don't know these things, you will have difficulty in completing the course. So please make sure that you study, give it more time. If you have any problem, let me know so that we can at least. I don't want to have anybody with lack of understanding. Okay. So and the quiz was the answer between the solution and the real efficiency and the quiz solution. So last time we started talking about the joint center moments, and we defined one of the most important joint center moment is what we call the covariance CXY, which is the expected value of x minus x bar minus e multiplied by y minus e, and it gives, as I mentioned, this gives basically how much related again the two random variables are, and in terms of correlation, the covariance equals the correlation minus the productivity, and we did the derivation answer. And we said that, okay, if we have uncorrelated random variables, then the correlation equals the productivity means, which means that the covariance equals. So we have covariance equals 0, we have two uncorrelated random variables. And we went through a very important concept, which is the correlation coefficient. We said that, okay, in order to know how much two random variables are correlated, covariance will not be enough. So if the covariance is 0, not correlated. However, how much they are correlated? Are they correlated very with highly correlated or lowly correlated? We need to have what we call normalized coefficient, and this is what we define as the correlation coefficient. Correlation coefficient simply if we normalize every part of the correlation, so x minus x bar divided by the standard deviation, and y minus y bar divided by the standard deviation. Then in this case, this gives me CXY, which is the correlation, divided by the standard deviation of x, standard deviation of y. Now this gives me a number between minus 1. So if the two random values are highly correlated, you will be close to 1. Close to 1. In this case, they are basically highly correlated. They move together. If random value x is large, usually you'll find that random value y will be also large most of the time. However, if they are negative, if the rho is very close to -1, -9.9, -0.8, then it means that x and minus y are highly correlated, or minus x and y are highly correlated. While if rho is close to 0, then it means that x and y are slightly correlated. However, if it is equal to 0, then it means that they are completely correlated. Okay? Any questions? Now we stopped at this scatter plot, and we said, okay, now if we are collecting regions, for example, we have 2 students. We'd like to see the performance of the 2 students in different exams. So, for example, we take student number x. Sorry, we have, for example, 2 students, student x and student y. Okay. Now, every time the student, exam 1 and exam 2, and we have many students. Then in this case, we will see every student how many, for example, student x, he took 170 in exam 1 and 50 or 45 in exam 2. So this will be 1 point for one student. Another student took, for example, 170 in exam 1 and 60 in exam 2. Okay, a third student took 170, however 110 in exam 2. And so on. So in this case, we are comparing what is 1. The random variable x is 1. The exposure of students in exam 1. بينما y will be the exposure of students in exam 2. So the scatter plot tells you the distribution of how the different scores that student took for exam 1 and exam 2 combined. So for example, in this case, the student took almost 145 ولا أكثر exam 1 and مثلا 15 exam and so on. So now if students are distributed randomly, it means that ما في علاقة بين the course حق الطلاب exam 1 and exam 2. They are scattered randomly. بينما if there is some shade, for example, here the correlation is 0. They are scattered randomly, equally likely. Now, as the correlation increases, you will see that there become some trend. يعني مثلا هنا نبدأ نشوف في ترند واضح. إنه الطلاب اللي يجيبوا في الاختبار الأول أحسن تلاقيهم جايين في الاختبار الثاني أحسن، والطلاب اللي جايين في الاختبار الأول سيء، الطلاب الثاني في الاختبار الثاني سيء، وفي الوسط So there start to be a trend. As rho increases, there start to be a trend. Now, when rho reaches, for example, here 0.95, 0.9, واضح الترند. Okay, شباب? For example, here 0.99, almost 1. 1 means what? Means that y equals a value ax. So we can see here that كل الطلاب طالب رقم 1 سيء في الاختبار الأول سيء في الاختبار الثاني. طالب رقم 2 كذا وكذا. بعدين طالب هذا ممتاز هنا وممتاز هنا. طالب هنا هذا جيد جدا. So basically there is a clear correlation between the exam 1 and exam 2. بينما هنا لا. There is no correlation. واضح؟ So the correlation coefficient tells you some information, not everything, some information about how much related the two random values are. Okay? باختصار لما يكون correlation 0, you will find that the scatter plot is extremely random. بينما لما يصير في trend line او يعني في trend يبدا يتضح يكون في correlation اعلى واعلى. هنا مثلا correlation 0.5 في شويه trend لكن مو زي هنا trend اقوى. تفضل.
أول negative 1 the correlation negative 1.
The negative 1 will be like this. It will look like this. يعني when x increases, y decreases. X increases, y decreases. Okay, so the points, the scattered dots will be the opposite direction. So simply x is correlated with negative y or vice versa. Y with negative.
The last picture, can we say they are dependent or not?
They are correlated, they are dependent.
If
they are uncorrelated, we have no clue that they are independent. If they are correlated, it means that they are not independent. Their independence is much stronger than independence. So if there is a relationship, it means that they cannot be independent. في علاقة بينهم. Like if they are uncorrelated and I have no clue about the joint PDF whether it is one entity. Right. ما أقدر أحكم. Okay. تمام. 0.4. 0.4 أقرب ل 0.1. So this is called slightly correlated. بينما 0.6, 0.7 is more correlated. كل ما ينزل ضوء تكون أصغر you can say that it's slightly correlated or less correlated. يعني أعطيك two pairs مثلا x, y و w, z. X, y have a correlation like this 0.2 بينما y و z w, z correlation 0.6 which are more correlated. There you go, okay, because the correlation option to the other.
correlate in coefficient
correlation coefficient.
يعتمد على الكوباية اسمه
يعتمد على الكوفيرنس. يس. طبعا هو الاسم هنا يجيك واحد يسألك طب ليش مثلا يكون correlation covariance coefficient. Well, it measures how much correlated they are. And كل ما the term correlation state. correlation لها معنى أكثر من covariance. covariance ما لها معنى. covariance ليش سموها covariance؟ لأنها زي الفاريانس. The way we calculate it, it's exactly the same as the variance. مثل الفاريانس. We subtract the mean. لكن instead of y minus y, the mean of y squared, the x minus x bar, y minus y. So it looks like the way we calculate the variance. And because of that we call it covariance. لكن لما تيجي الآن تسمي coefficient that indicates how much two random values are related. هتسميه covariance coefficient ولا correlation coefficient. العلماء قالوا لا والله it looks like it sounds better than correlation لأنه it reflects the mean. لكن هو ما له علاقة بالcorrelation، هو له علاقة بالإيش؟ بالcovariance. It's a normalized covariance. حسب القسم. أوكي يا شباب؟ طيب الآن we understand the scatter plot and what does it mean and علاقته بالcorrelation coefficient. Now we are putting here different correlation coefficients. هذه كل الفيجرز اللي هنا on the right كلها has a correlation coefficient of 0.7. Okay? هذا شوف هنا في one outlier pulled the data such that it made some correlation of 0.7. Then if you ignore this, لكن تقريبا correlation is very small. لأنهم almost direct. هنا correlation is almost highly correlated بينما هذه outlier بدون هذه تقريبا correlation كم؟ تقريبا 1 يعني very close to 1. At this point pulled the correlation down to 0.7. Similarly here you have two lines. If you ignore one of them, it's highly correlated. بينما two lines basically they confused the correlation to make it smaller. هنا واضح انه في خلينا نقول ترند لكن الترند ما هو قوي لدرجه انه يصير highly correlated. So because of that it became 0.7. هنا عندك two clusters. Cluster number 1, cluster number 2. لو if you take one of them, correlation coefficient is كم؟ almost zero. صح ولا؟ لو تاخذ هذه الواحده almost zero. لكن when you combine them, they become a trend. هذا اللي يخلي الكوفيشنت اكثر من 0.7. Here, for example, there is a trend واضح لكن almost highly correlated, but because of this part, the correlation coefficient becomes. The objective of showing you this, tell you that one correlation coefficient doesn't tell you the whole story. It only gives you a notion about the two random values that they are related. واضح؟ لكن ما يعطيك أي معلومة عن how يعني ما يعطيك أي معلومة basically يعطيك missing خلينا نقول معلومة ناقصة. لكن it's a useful information. مو زي independence، مو زي independence. Independence gives you full information. However, this gives you some information that is not always accurate. With that لما يكون عندك outliers. When you have outliers, this will miss the correlation. عشان كده دائما الناس اللي يسووا statistics first of all, after collecting the data, you need to do what? هذا يسموه ايش؟ cleaning the data. Cleaning the data to make sure that you remove the outliers. The outliers تخرب لك الداتا. يعني مثلا when you take an exam واحد ما شاء الله ممتاز أو واحد جايب صفر. This will distort الأفريج. الأفريج ممكن يكون مثلا 70 لكن واحد جايب صفر يبوك الأفريج يسوونه 65 62 الناس يطلع واو الأفريج 62. بعد كده رجع على الجواب ايش يصير في الأفريج؟ يرجع 60 صح يرجع 70. So the outlier in many cases basically distorts the data. And because of that, usually you need to clean your data by removing the outlier. ما يعطوك but they don't represent the statistics of your values. الآن هنا we are showing a negative correlation. سؤال زميلكم. Here we have positive correlation, so this is positive. Here we have negative. Negative. Okay, positive though, you can see that the trend is upward, means that x increases, y increases. بينما negative though, x increases, y decreases. هنا rho is very large, negative, minus 0.9. Here it's minus 0.5. Here it's 0. طبعا 0 تلاقي انه خلاص ما في relation. واضح انه circle. There is no trend. So here the trend is negative. اوكي يا شباب؟ Now let's have an example on the expected value of a function of random values. نتذكر we did this. If we have x equals summation of alpha I xi, I equal 1 to we found the expected value of x, which is the expected value of whatever inside here is the expected value of the summation, صح? And we were able to find that this expected value equals the summation of alpha I multiplied by the expected value of everyone. We did this. So the average of a weighted sum of random variables equals the weighted sum of the individual values. Okay? Now, what about the covariance? So basically, we did this already done. We need to do now to find the covariance of x. Okay? In order to find the covariance of x, first of all, we subtract x minus x average. When we subtract x minus x هذا minus the average هذا هسه عندنا summation of alpha I x minus xi minus xi. Now, what is the variance of x? هذا هو السؤال. أنا عندي الآن المين حق الx أبغى الفاريانس. I simply find the expected value of this. x minus x bar square. Now أنا عندي الx minus x bar, right? هذا عبارة عن alpha xi minus x bar. But هذا عبارة عن multiplied by this, right? X minus x bar equals the summation of alpha I x I minus x bar. So basically, if I take the square, I multiply this summation by itself. So I have a summation over I 1 to n. I have summation over j 1 to n. Alpha I xi minus xi bar, alpha j xj minus xj bar. Now I have double summation. What do I do? What do I have? When I multiply them, I have double summation, right? So what do I have? Alpha I, alpha j, is it? Double summation over I and j, alpha I, alpha j, alpha I multiplied by alpha j. And then expected value, طبعا احنا قلنا summation دائما ناخذ expected value inside, right? We take it to inside only the random part. أي شيء constant يطلع برا. So alpha I, alpha j are constant, so they get outside. And we have expected value of what? xi minus xi bar, xj minus xj bar. Right? What did we call this? Covariance of xi and xj. Right? So what do we have here? We have double summation I and j, alpha I, alpha j, covariance of xi. So the variance of x equals the double summation of alpha I, alpha j, xi and xj. Now, what happens if xi's are uncorrelated? In هذه x's, yeah, basically x is a summation of weighted sum of uncorrelated random values. In chapter 3, chapter 4, when we have two independent random values, in PDF was the convolution, right, of the two videos. Here, if we are summing x, which is weighted sum of uncorrelated random values, uncorrelated. So what happens to in covariances here? 0 when I not equal to j. x1 and x2 covariance حقتهم 0 because they are uncorrelated. x1 and x3 covariance حقهم 0, right? And so basically cxi xj equals 0 when I not equal to j. And what does cxi xj equal when I equal to j? What do we get? the variance of that I. Okay. So basically, it's the variance of xi when I equal to j. It's 0 when I not equal to j. So now the double summation أنا عندي هذا متى؟ هذا بس non-zero when I equal to j. So double summation will boil down into single summation of alpha I where x sigma xi squared. The variance. Yeah. So the variance of x when we have uncorrelated is equal to the weighted sum of the variances of x. لكن الويت هنا بدل ما كان alpha I مثل المين it will be alpha I squared. لا لأن أنا بس أضرب summation في summation. لما أضرب الآن x زائد خلينا نقول a زائد b multiplied by c زائد b. What do I have? How many terms? 2 terms only ولا 4 terms? صح؟ So basically every term here multiplied by every term here. And because of that we have double summation. Alpha I, alpha j, and so on. Yes.
X is 1.1.
X is summation of weighted sum of xi. Xi, every one of them is non-divided. Alpha I are constants, weights. Okay, so here in هذا الملخص, the variance of a weighted sum of uncorrelated random variables with weights alphas equals the weighted sum of the variances with weights alpha squared, alpha I squared. بينما المين كان weighted sum of the mean value. I would love to have an example before I continue. An example. Let's have an example. Okay. Now we have statistically independent random variables x and y. I am telling you that they are independent. Independent means what? Conjoint together equals the product of the multiples. I know how they are correlated or uncorrelated. So this is the first information that you know. And they have the mean x bar equal 1, the mean xy bar equal minus. The second moment, I'm giving you that x, which is expected value of x squared equals 4, and expected value of y squared equals this. Another random variable is defined as w, which is equal to a function of x and y. Let me check. It's 3x squared plus 2y. The question is plus y. Huh? The question is find the variance of x, variance of y, correlation between x and y, covariance, the mean of y, w, and the correlation between w and y. So كل الكلام اللي درسنا في lectures نتكلم عنه الآن we'll do it for one example. طيب شباب. So we start with what? The variance of x. Why don't you do it? Let's take a paper and give me the variance. Okay. All right. Yeah, let's get done. First, the benefits. Yeah. How to find it? I did not give you a PDF, so you cannot just tell me that it's x minus x bar PDF. You can write this, but you will go nowhere. How to find it? You have enough information or not? So this is equal to what? Oh. Yeah, x squared minus x bar squared, which is equal to 4. Yes, ناقص 5, which is. Right, what about the variance of y? يلا شباب مين حصل variance of y؟ 3/4 because it's 11/4 minus كم؟ minus half square, right? So 11/4 minus 1/12, which is 10/4. Okay. Now we know two variances. What now? Next, what is the correlation coefficient? So the correlation between x and y. ماشي يا عبيد. دائما نرجع للديفينيشن اذا انت ملاحظ. What is the correlation coefficient? What is the correlation? تمام. Yes, always if you get confused, always go back to the definition. So now how to do it? ولا otherwise في الصح تقول وما اعطاني البي. Otherwise if they are not independent, what do you need to do? You need to integrate x multiplied by y to join PDF. صح ولا لا؟ But you don't know. I didn't give you the PDF. معناها ايش؟ You need to use your information. They are independent. Independent means uncorrelated. صح؟ So what do we get if they are uncorrelated? Yes. Because independent. Which means uncorrelated. تمام. Now x bar y bar equals what? Minus. So 1 multiplied by minus half, which is minus half. Now what about cxy? The covariance between x and y. Why did you take 1 minute to do it? Try to work now. ماشي حصل covariance. Why is it 0? طيب هذا x y. طبعا again إذا ناسي المعادلة هذه, you can always go back to the definition. Minus كم? x bar y bar. صح؟ نحن we know طبعا you can go through this and so on. لكن can you know that it's 0 before that? Why? I gave you it's independent. Independent means uncorrelated. Means that this is equal to 0. لكن anyway, في واحد ما انتبه. Let's do it. Rxy, which is minus half, right? Minus half, which is already calculated, which is 0. And we know that this is 0 because uncorrelated. So we know that before. So if you forget this, Shabab, you can always go back to the definition and open up the square. يعني مو شرط انك تذكر كل حاجه. You can write this as expected value of x minus x bar, y minus y bar, right? And then simplify this as open up, which gives you x r of xy minus x bar y bar plus x bar y bar minus 2, which will be equal to rx y minus x bar. So even if you forget it, you can always go back and do it by understanding what the definition of the equivalency. Right. What is the mean of W? Yeah, the mean of W is ايش نسوي؟ Expected value of W, صح? Now we just simply نعوض في W. What is W? What does W? 3x square plus 2y plus 1. Right? So this is equal to come. Now expectation is a linear operation, so we can just separate them. So this is expected value of x squared, 3 expected value of x squared, صح? Plus 2 expected value of y plus 1. Now those who calculated it equals to chemistry. 12, huh? I believe. So what else? Now the correlation between w and y. What is this? Yeah, you always write the definition, w, expected value, w and y. But what is this equal to? What do we do? Integration of what? Wy in the joint PDF of w and y. Do you know the joint PDF of w and y? Do you know the PDF of the y? Did anybody give you any PDF here? We need to use the available information. حتى أنا ممكن أعطيك تريك أسوي أعطيك فيديو. Will you do the double integration? You will waste your time. You will spend 15 minutes doing integration while it's only a simple arithmetic. Simply, you just write what W is. So what do we have here? W is already given, صح? So we have Y multiplied by 3x squared plus 2y plus 1. Now, what we did here is we substituted for W. Now we just open up things and use the linearity. So what do we have? We have 3 expected value of m x squared y plus 2 expected value of xy, right? Plus expected value of y, صح? y 2y squared, thank you. And xy, sorry, why did I say xy? Thank you. So 2y squared is, there's no x. Okay, so how to open up these things? أول واحد independent, صح? So because they are independent, x squared. Because they are independent or uncorrelated, then basically this becomes 3 expected value of x squared alone, y bar alone, right? And then the next, this is twice expected value of y squared, which we know. What is expected value of y squared? 11 over, so no simplification. Plus what? Expected value of y, which is minus 11 over 2, thank you. There is a 2. So it's 2 multiplied by 11 over. And then, so what is this? This is the fifth value of x squared, which is given for multiplied by minus half, blah, blah, blah. How much is it? Yeah. Minus 6. I believe. Right. Now you can find also the covariance. I have a proven here. Yes, you can do it, right? What is the covariance of y? It's the RWY, which we found already, minus W bar y bar, right? And we have this, we have this, we have this, we can write. Now we want the correlation coefficient between W and Y. What to do? Nice one. The correlation coefficient, W and Y. Now this is already, we know this, we calculated this, we know W bar, we know Y bar. So we can calculate this. Identify this. Okay, find it out. Now what about rho W Y? The correlation coefficient between W and Y. What is it? It's the normalization. It's the covariance of WY divided by the standard deviation of W standard deviation of y. Right? So you need to find, we have this already, it's the square root of the variance. So you need only to find the variance of W and then take the square root of it. So, yeah? Many. Can negative one? ما ادري انا واحد قال لي I trust you اسمع. Don't give me please something. Fine. Thank you. So now, in order to find this, we have already the numerator, we have sigma squared. So this you need to find sigma W squared and then take the square root. Well, لازم يطلع لك رقم ايش شكله؟ From -1 to 1. If you get something more than 1 or less than -1, then you get something. نروح للاشياء اللي تشكل الانسر. اوكي. ليه سؤال؟ هذا هو This is like the average زي الاكس بار. In an average يعني this is the way we in some books they write it. مثل ما كتبنا ال expected value x bar as expected value of x. Some textbooks they write expected. If I write the bar above x squared, this means that this is expected value of x squared. It's a way to write it. Basically, when you write the bar above the x squared, means that expected value. This is just a notation. Notation. Thank you.
Only we find the variance.
Okay. How will we find the variance of the value? It's the expected value. It's يعني هي ناخدها. طبعا you can write expected value of W minus W bar. لكن the easier way to do it is expected value of W squared minus W bar squared. Right? We know this already. We calculated it. You need to calculate this. How to calculate it? Just plug. This is equal to what? Expected value of 3x squared plus 2y plus 1 all squared minus W bar squared. So what is this? You will have to square 3 terms and then simplify. Okay? You might end up being able to find it or not being able to find it given the information. And we could like expected value of x to the power 4. We don't know. But given this information, we don't know. لكن إذا ما أعطى المعلومات you can find it. طيب, great. Any questions? Going back to where we were. Now, one thing that we would like to discuss about the joint characteristic function. نفس الكلام اللي تكلمنا عنه في الجوint PDF. Now we talk about the joint characteristic function. Joint characteristic function of x and y is a function of two values, W1 and W2, omega 1 and omega 2, which is the expected value of e to j omega 1 x plus j omega 2 x. So here we have here two exponents. And if you look at it, it will be the PDF multiplied by the exponential of the two values. هذا نسميه two-dimensional Fourier transform. Two-dimensional Fourier transform. Basically, you are doing Fourier transform for two variables. Right? And the opposite for that operation is the inverse, the two-dimensional inverse Fourier transform, which will be the characteristic function, and then e to minus g. Here e to j, here e to minus g. Here we integrate with respect to x, y, here with respect to omega 1 omega 2. Okay? Now we define the marginal characteristic function when we put 0. So omega for the characteristic function of x, we put omega 2 as 0. So if omega 2 is 0, you end up with this exponent. being 0. So basically, you expected value of j omega 1 x, which is the definition by definition, the characteristic function of x. Similarly, for y, if you put omega 1 as 0, you will get the characteristic function. Now, why is this important? Because of the joint moments. M and k, the joint moment, M and k, which is the expected value of x to the power n, y to the power k, and a joint moment. Now, we can find it instead of doing integration that is extremely difficult, we have to remember single value variable. No, we can differentiate the characteristic function n times with respect to omega 1 and k times with respect to omega 2. This is x to the power n, so you differentiate n times with respect to omega 1. Y to the power k, so you differentiate k times with respect to omega 2. And then you take minus j to the power d. Addition, set omega 1 0, set omega 2 0, you get this. The very complicated, hugely complicated integration ends up into differentiating the one characteristic function several times and then setting the values. Much easier. Okay. Now, if I have two independent random variables, x and y, independent, then what can I say about the joint characteristic? About how can we, so phi xy of omega 1 omega 2. What is this? This is the double integration of the joint PDF e to j omega 1 x e to j omega 2. What about if I have independent random variables? This PDF exactly will be the product of the two margins. So I will have fx of x, fy of y, and they have complex exponential of x, complex exponential of y. Can I decouple the integration? It will be decoupled into phi x of omega 1, phi y of omega 2, because of the d. So if I have y and two independent random variables, then the joint characteristic function will be also the product of the individual characteristics. Similar to what we have in the joint video. Well, so this is basically was one thought here. Now let's talk about, at the start at least, talk about a very important concept, which is the jointly Gaussian random values. Jointly Gaussian random values are, we'll start with two, and then we'll talk about in general, like we focus only on two random. So two random variables, x and y, are said to be jointly Gaussian. Now, x is Gaussian matter if x is Gaussian with certain mean and certain values. What does this mean for us that PDF looks like? ايش البي دي اف حقت الاكس؟ 1 over احد ذكرها 2 pi sigma x squared, right? Exponent of minus x minus the mean squared divided by 2 sigma x squared. So if x is Gaussian with mean m and variance sigma x squared, the PDFs look like this. Now, if y is Gaussian with certain mean and certain sigma y squared, it will look the same, except the mean will be different and the variance will be different. So now two random variables are said to be jointly Gaussian if they follow this PDF. الPDF حقتها شكلها كده. شكلها شوي معقد لكن it's not that complicated. أول جزء is the same as for x. X minus x bar squared divided by sigma. آخر جزئية is the same as for y. If y is Gaussian, you will have the same as this, right? So it will be y minus y bar, which is the mean, divided by y sigma y squared. اللي في النص connects x and y through correlation coefficient. In the correlation coefficient, if two random values are independent or uncorrelated, then the correlation coefficient will be 0. معناها هذا مش موجود. كل الترم هذا يضرب. إذا هذا الترم راح إيش يصير؟ إذا عندنا this term plus this term. So you can separate, you can decouple the exponential into two exponential, واحد للx واحد للy. So it will be like the PDF, this will be like the PDF of x multiplied by the PDF. واضح؟ شباب. Again, this PDF looks like complicated. شوي نفصصها. أول جزئية looks like the PDF of x. Constant multiplied by exponent to minus x minus x bar divided by sigma square. واضح؟ آخر جزئية نفس الشيء لكن بالنسبة للواي. اللي في النص is what connects y with x. العلاقة بين y و x. إذا في علاقة قوية rho will be large and this part will be large. إذا ما في علاقة, إذا correlation is 0, then this will be 0 or close to 0. واضح؟ Now, if we plot this joint PDF versus x and y, so this is the joint PDF. So it will be x, y, and the joint PDF. So it's a three-dimensional one. It will look like this. هذا نسميه البيل شيب. بيل شيب PDF. ليش بيل شيب؟ شكلها زي ايش؟ زي الجرس. اوكي؟ It will look, لو تتذكروا الجاوسن كان شكله كذا في one dimensional. Right? Now imagine this in the two dimensions. It will look like a bell shape. The x will y. And if the variance of x is larger than the variance of y, كيف شكل البل بيصير؟ هيصير في الاكس واسع بينما في الواي ضيق. هيصير كانه بل، كانه جرس لكن منتفخ في الاكس دايركشن، في الواي دايركشن نحيف. بينما اذا الفاريance of y is larger, it will be the opposite. It will be wider in the split اكثر في الواي وفي الاكس. الان when rho is 0 هذا هنتكلم عنه بعدين. Next time, inshallah. Thank you very much. And we'll see you next quarter. Slack, that's right. The exam will be 5:30. Is that okay with you? Say it public. Guys, the public. علاء الشكور. براء. ميال السبب.